Hello everyone. In this video, we are going to talk about interface segregation principle. It states that the classes should not be forced to depend on interfaces they do not use. Instead, large general purpose interfaces should be split into smaller and more specific ones so that each classes only implement the methods relevant to its functionality. So the main goal of ISP is to avoid fat interfaces. By fat interfaces, I mean the interfaces that contains many methods, some of which may be relevant to all the implementing classes. By breaking down large interfaces into smaller role-specific ones, code becomes more modular, easier to maintain, and less prone to unnecessary dependencies. Now let's understand it through example. The whole example is very apt to the current scenario. Here you can see that I have an interface that is iWorker. Let's suppose in a company there are workers. They could be robot workers, they could be human workers, and we decided to write only one interface for it. Maybe we started with human worker and we wrote one interface only, that is eat, sleep, work on assigned tasks. Okay, but later on when the robot worker came, we added more methods which robot worker should implement. That is charge and battery percentage. Along with this, it is going to work on assigned task also. But what is happening here, that human worker now should also provide body to charge and battery percent left method, which doesn't make sense at all. And at runtime, if somebody calls this charge or battery percent left method for human workers, it should throw an error, which is a big issue here. And the same for robot worker also. Why it should eat and sleep? Robot worker should not be forced to implement methods which it does not need to use. Robot worker does not have to eat and sleep and should not do anything which they do not need. So here ISP is unsatisfied. The interface segregation principle is clearly unsatisfied here. How to make this particular thing compatible to integration segregation principle? Now you see that I have a iWorker interface, same. So for every worker, what are we trying to expect? We are expecting that they should work on the assigned tasks. This is a pretty common method which will be implemented by worker no matter what worker is there, be it human, be it robot or anything. And now we have segregated this interface into specific ones. For example, iEatable, iSleepable, iChargeable. I could have added iWorkable also, but since I see that all the worker should be having this work on assigned task method, so I have extended all these interfaces with iWorker itself, because this will be common for no matter what worker is there. Now if I have a human worker, I should implement iEatable interface and I should implement iSleepable interface. I do not have to implement iChargeable interface because it doesn't come under my functionality. Work on assigned task is already coming from these two interfaces, which is already extending iWorker. Similarly, for robot worker, doesn't have to implement iEatable, iSleepable or anything of those sort. It just have to implement iChargeable interface. And the work on assigned task is coming from iWorker. Now robot worker, what methods it would have? Work on assigned task, charge and battery percent left. All these make sense for robot worker? Yes. For human worker, what it should do? It should eat, sleep and work on assigned tasks. Does it make sense here? Yes. So ISP is satisfied here. And this is a very simple principle. I hope you understand my point. Now coming to the benefits of ISP. So since there are a smaller interface, code will be easier to understand and maintain. There is reduced coupling here because classes are only coupled to the method they need, making the system more flexible and easier to refactor. Again, there is improved scalability because new features can be added by introducing new interfaces without affecting the existing code. That is it for the video. I'll see you in the next video with dependency inversion principle. Thanks.